It's so great to see so many familiar faces, or familiar names, I guess. It's nice after having been in the role for about a year, I start to recognize names and start to recognize people. So hopefully you know me. If not, you're about to meet me. So I'm Erin McLean, the Community Engagement and Outreach Coordinator for the Arctic Data Center. And thanks to IARPIC and to Liz for inviting us to do an introduction to data sharing and reuse with you all. I hope everyone's doing well and feeling healthy as we go into the December holidays. I'd like to also acknowledge that I am on the traditional lands of the Chumash and the Barbareño tribes, and I love that this is becoming a standard practice moving forward. So what I'm going to do today, I'm going to give a quick overview of the Arctic Data Center, and then give you a tour on how to access the data within our repository for reuse. Before I get into that, I do want to point out that we recently added a new logo to our first slide. We're officially Core Trust Seal certified, which means that we've met 16 pretty rigorous requirements of trustworthy repositories. So I'll start off our hour by giving a quick introduction, then discussing the features and services that we offer for the Arctic research community. Then I'll move into talking about the data from the perspective of both submitters and reusers, since having both perspectives is useful whether you plan to submit a data set or reuse one. Then I'll close out by giving a demo of the search catalog and other resources available on our website. Finally, I'll take any questions. So feel free to pop them in the chat as we go. Liz is going to be doing the moderating, and I promise to get to all of them at the end. And if we don't have time, I will email and follow up with the answers. So data reuse is at the very core of our mission. We are committed to making sure that our data is discoverable and reusable by researchers. So to that end, not only do we have raw data sets, but we also encourage researchers to upload software, code, and packages, as well as the provenance of data products. And I'll get into what that means a little bit more later. All of the associated products that we have are available for download and reuse. We're best known in the research community as a data archive. Researchers are uploading their data to preserve it for the future and make it available for reuse. This isn't the end of that data's life, though. Sorry, that's not even my dog that's barking. These data can then be downloaded by researchers like you for different analyses or for synthesis projects. So in addition to being that data discovery portal, we also offer top-notch tools, support services, and training opportunities. I won't focus on this today, but we also do provide data rescue services. So these 6 graphics kind of illustrate what we're all about. We have a number of tools available to submitters and to researchers who are there to download data, like the metadata completeness check, the online metadata editor, and the metric service, which tracks information associated with the different data sets. We also partner with other organizations like Make Data Count and DataOne, and we leverage those partnerships to create a better data experience for everyone involved. If you're not familiar with DataOne, it is a community-driven project providing access to data across multiple member repositories. And I think that number is up to 45 member repositories right now. And what that does is it supports enhanced search and discovery of Earth and environmental data. And we leverage our partnership with DataOne as a DataOne member node so that Arctic data in the Arctic Data Center shows up when you search across the DataOne catalog. That said, the Arctic Data Center is certainly not the only place you can find Arctic data. There's a number of different DataOne member repositories, which are all shown in this graph, as well as others that are not DataOne member repositories that all have different subsets of Arctic data. It's a big field, there's a lot going on, and we're hoping that everyone's able to access all of that data. We know that data quality is important for researchers to find data sets and to have trust in them to use for another analysis. So in order to make sure that data quality is up to snuff for every submitted data set, the metadata is run through a quality check to increase the completeness of the submitted metadata record. So these checks are seen by the submitter as well as are available to those that view the data, which helps to increase knowledge of how complete their metadata is before they submit it to the Arctic Data Center. So that way, the metadata that is uploaded to the Arctic Data Center is as complete as possible and close to following the guideline of good metadata, which is that it is understandable to any reasonable scientist. So that metadata quality check, that's the automatic way that we ensure quality of data in our repository. But the real quality and curation support is done by our curation team. So the process by which data gets into the Arctic Data Center is iterative. which means that our team works with the submitter to ensure good quality and completeness. So when a submitter submits data, our team gets a notification and begins to evaluate that data for upload. They then go in and format it for input into the catalog. And in that process, they communicate back and forth with the researcher if anything is incomplete or if it's not communicated well. This process could take anywhere from a few days or a few weeks, depending on how big the data set is and how quickly the researcher is able to get back to us. So if you're going out to the field for a while, that'll put a delay on it. But once that process is completed, that back and forth, the data set is published with that DOI. In addition to the tools and support services that we offer that are more on the technical side, we also spend time interacting with the community. So my job is entirely focused on training and outreach. And so part of having my role is to create a robust relationship with the community of both submitters and folks that are there to download and look at data. So I hope you all have the opportunity to attend one of our trainings at some point. We train on reproducible research and open data science skills. We hold these trainings once or twice a year, and they are open to everyone actively involved in Arctic research from undergrad on up to Professor Emeritus. We actually just hosted our first ever virtual training this past October, and it went really well. And so we're excited to have more trainings on the calendar for this next year, 2021. We're thinking we may have a hybrid model where one's in person and one's virtual, but we're still trying to work out the details on that. If you want to get ahead on your data science skills, maybe you're not traveling this winter, and so you have a bunch of time open, you can certainly check out our instructional materials, which are all open source and available to download on our training website, training.arcticdata.io. We also run workshops at conferences like the Ecological Society of America and the American Geophysical Union, which just happened. And as further education and outreach, we also run an internship and a data fellowship program, as well as me doing webinars with folks like you every month or two. We're really invested in helping to train the Arctic science community in these reproducible techniques because it really facilitates a more open culture of data sharing and reuse. We also strive to keep our fingers on the pulse of what researchers like yourselves are looking for in terms of support. So I'm super active on Twitter to share Arctic updates, data science updates, as well as different funding opportunities or even job opportunities. But I'm also really happy to feature new papers or successes that you all have had working with the data that's in the catalog. If you find that you run into a data question in the course of your research or struggling with your data management plan or something like that, you can always feel free to either shoot us an email message or tweet us on Twitter, and we can happily answer whatever question you have. I love having researchers interact with us because we really do love to be involved in your research as it's happening, as well as after it's completed. All right, enough about us, on to talking about the data. Data is the real star of the show here. So NSF has long had a commitment to data reuse and sharing. Since our start in 2016, we've grown substantially. We started with 4 terabytes of data from a caddis, and now we have over 54 terabytes of data. In the last year alone, we've seen a 16% growth in dataset count and about a 30% growth in data volume. This increase has come from advances in tools, both our tools, but also the tools of scientific community, think remote sensing data, as well as active community outreach, and more importantly, a strong culture of data preservation from NSF and from researchers. We plan to add more storage capacity in the coming months because researchers are coming to us with datasets in the terabytes. And so we're excited to preserve those research products in our archive to keep it for the future. We're projecting our growth to be around several hundred terabytes, which is going to have a big impact on processing time. So do us a favor, do yourself a favor, and give us a heads up if you're planning on having a larger submission. That way we can work with you and be prepared for that large influx of data when you're ready. So what all is encompassed in that 54 terabytes of data? As it stands right now, we have a lot of it. Over 6,200 data sets, and again, all of them are available for download and reuse. We have almost 6,000 individual data, or over 6,000 individual data sets, excuse me. And we define an individual data set as a single metadata record that describes one or more raw data files. So that can mean there's a metadata record with one CSV file, or a metadata record with several PDF files, scripts, CSV files, images, the whole 9 yards. We track metrics about the data, as I mentioned a little bit earlier, to get a better idea of how the data in the repository is being used. One of the most obvious things to investigate is how often the data is being looked at. And we try to filter out most views by internet bots or repeat views within a small time window in order to make these metrics counter compliant. If you're not familiar with counter, it's an acronym. I can never remember what it stands for, but it's a standard that libraries and repositories use to provide users with consistent, credible, and comparable usage data. So we track these metrics both on the scale of our entire catalog, which is what you're looking at here, but also on the scale of the individual data set. This is the downloads for an individual data set, which we track on the same way as views. The data that we have in the Arctic Data Center comes from a wide variety of disciplines. So these different programs within NSF all have different focuses. So like, for example, the Arctic Observing Network, that first bar, supports scientific and community-based observations of biodiversity, ecosystems, human societies, land, ice, marine and freshwater systems, and the atmosphere, as well as their social, natural, or physical environments. That's a lot of disciplines right there in just that one program. I'll give an example of some data sets from particular disciplines when we dive into the demo of the catalog to give you an idea of the variety. We're also working on a way to classify the data sets by discipline. So keep an eye on that coming soon from us. So along with the diversity of disciplines comes, of course, a diversity of file types. The most common file type we have are image files, which you can see in this in 4 different ways, whether it's a JPEG, a PNG, a GIF, or a TIFF, or a GIF, depending on how you're supposed to pronounce it. Probably less than 200 or 300 of those data sets have the majority of those images. We have we have some large data sets that have image or audio files from drones, but most of those 6,000 plus data sets are tabular data sets in a comma separated value sheet. So whether you want to look at remote sensing images, listen to passive acoustic audio files, or run applications, we have it all. We also cover a long period of time, at least by human standards. The data represented in our repository spans across centuries. This word cloud shows the diversity of the data in a different way by seeing the number of data sets using particular connected keywords. As you can see, we have a great deal of titles using the word Alaska, as well as a big chunk of data sets with photo scans from aerial surveys. One of our data fellows that I mentioned is working on a more in-depth analysis of this, and this is her preliminary work on that topic. So who has to submit? Data that we have in our collection is added to or updated almost every day due to the requirements of submission. So projects that have to submit their data include all Arctic research opportunities through the NSF Office of Polar Programs. That data has to be uploaded within 2 years of collection. If you're with the Arctic Observing Network, you've got a shorter timeline. Their data products have to be uploaded within 6 months of collection. Additionally, we have social science data, though that data often has special exceptions due to sensitive human subjects or other types of protected data. At the very least, it is required that metadata is deposited with us, if not the raw data itself. Here are 2 examples of social sciences data sets that we do have in our repository. The first one is from Matthew Berman about educational attainment among American Indian and Alaska Native individuals. And the other is from Laura Zanotti examining gender roles, in an Alaska Native community. So they do exist, and we're working with social scientists to help increase the number of social science data sets that we do have. The data that we have in our catalog is licensed at the time of upload as either CC0 or CC BY. The distinctions are listed on the slide, but the takeaway here is because we license data in this way, these data are able to be reusable and downloadable for synthesis work or other studies. Data citation is a practice that everyone should be in the habit of doing. To make it easier to cite, we assign a DOI to each published data set. So not only does that help researchers be cited more often, which is good for them, but it also promotes a more transparent process of tracking the data used in papers. I have another data fellow who's working on a way to automatically collect a list of publications that have used Arctic Data Center data. But as of right now, a researcher has to point us to the associated publication from a particular data set if it's not directly cited. We're really trying to understand when researchers are using data sets but aren't citing them. So this is where you can come in. If you have citations where you know of data usage, let us know. We just updated our website and it allows folks to submit publications that are associated with those data sets. And one way that you can be part of this solution is by always citing your data formally, not just this, like in the methods, data are archived here. If you cite it formally in your citations, even if it's your own data, that'll help us and other repositories solve this issue of data citation. Our data fellow who is working on this, her name is Maya. She recently gave a great presentation at AGU about this topic, and the recorded talk is up on our Vimeo channel. So I'll be happy to hunt down that link for anyone who's looking for it. We also provide support if a data set needs to be updated by the researcher. So each update will get a unique identifier so that the exact version that the exact version used can be cited. DOIs and URLs for previous versions of data sets remain active on the Arctic Data Center, which means that the identifier will continue to resolve to the dataset landing page for the particular version that it's associated with. If there's a new version available, you'll see this yellow message. A newer version of this dataset exists with a hyperlink to the newest version. With this approach, any past uses of a DOI, like that would be cited in a publication, those will remain functional and will reference the right version of data that was used. So like I mentioned, metrics on each data set are tracked. So I talked about views and downloads, but we also track citations. This is the one that's a little bit tougher to do, but this particular data set from Hioiken has 5 papers that use that data. This is our brand new register citation feature that I mentioned. Since it's difficult for us to complete programmatically, difficult for anyone to complete programmatically, we're hoping you can help us out. So if you do know, you'll click on the citations and then you'll hit plus register citation and just paste in whatever DOI of that publication that uses that data set. Once you do that, the citation will be viewable on the dataset profile within 24 hours. So it's a cool way to see how often data sets are being used. So now to talk about some data and metadata best practices. For folks who are submitting data, we suggest a number of best practices to follow so that data are the most open for reuse as possible. So I wanted to highlight a couple of those best practices because I find that these are always helpful information, and even if you heard them before, you might learn something new. So the first best practice is to put all data in open or non-proprietary formats. So Microsoft Excel files right now are pretty commonplace, but no one, well, I don't know if it's possible to open an Excel document from the 1990s. So it's a lot easier to export the spreadsheets that you're using in Excel to what's called comma-separated values text files. Those can be read on any computer without having Microsoft products installed. So we encourage folks to move those proprietary formats to plain text formats. So Excel to CSV, GIS to shape files, and MATLAB to NetCDF. Those are the common ones that folks need. Another best practice is to have nice, clean data tables. So I'm showing you a bit of a nightmare here. This is a data table with embedded comments and empty cells and summary values in the same columns as observations. This is a nightmare for someone else to try to reuse. You'd basically need to have been the data originator to make sense of this particular data sheet. So what we encourage researchers to do is to use tidy data in a long rather than a wide format. And we've done a bunch of different talks on this. I have a couple of different recordings and can point you to a number of different resources if you'd like more information about ideal data management. We also encourage naming conventions to be descriptive and values and cells to be strictly numeric. That all makes it a lot easier for you to describe in the metadata and a lot easier for someone else to be able to reuse. So rather than a file name like this, make it something that makes sense. We've got a date, we've got a site, and we've got what it's measuring. Instead of SP, call it species count or something descriptive. And then rather than putting decimal degrees or coordinates in that format, you want to use decimal degrees instead. Another good practice is to put only one value in every cell. So separate ranges like this into an upper bound and a lower bound. So those are just a few, really a handful of the best practices, but there are plenty more that we encourage as well. And if you need help with your data management and organization, reach out to us. We're always here to help whatever problem that you run into. We can probably help you solve it, or at least we know someone who can. In addition to those best practices for data, we also encourage the following best practice for metadata. And for those who aren't familiar, metadata is defined as data about your data. We tell submitters to gather together metadata that describes your data, including information about the name and identity of the data, the geospatial coordinates where it was collected, when it was collected, and by whom. For people, you'll want to have their names and contact info, as well as an ORCID identifier for them. Our PI, his name is Matt Jones. It's a pretty common name, so it's a lot easier to have his ORCID. It's essentially his researcher barcode so that we know which Matt Jones submitted the data. You'll also want to have a good complete set of text describing the methods used to collect the data, as well as experimental design and sampling layouts. The goal basically is to have enough information so that a reasonable scientist can interpret the data without having to consult anyone or any other resources. And that should be true today as well as a century from now when methods change. We should still be able to try to be able to go back and decipher what you did with your data. So with that, I will dive into a quick demo of the Arctic Data Center catalog. And bear with me as I change all my Zoom windows up. You should still be able to see my screen. Wonderful. As well as my Spotify, so you can see what I'm listening to. This is the Arctic Data Catalog. It is the gateway to everything that we have available on the web. So the web address is arcticdata.io. And we put it pretty clearly on the front page. If you're there to search for data, submit new data, both of those buttons are there for you. So I'm going to click the search for data button. And here you're looking at the entire catalog. You can narrow your search down by the map area. You could do a general keyword search, or you can search by any one of these different attributes. So we'll take a start with the map. This map is interactive and updates the data as you zoom in and move around. So let's take a look. I'm interested in Greenland today. So I'll scroll over here. And this shows me all of the data sets that are in that particular map area. So I'll go ahead, take a look at this one. This is a data set from Julia McKnight. It's got a CSV file associated with it. It's got an application file associated with it, as well as the metadata format. This particular data set is about soils, whether it's carbon flux, moisture, and temperature at that tundra site in Greenland. You could download all these files with this green download all button. That will zip together all the files to your downloads folder. Or you can also pick and choose specific ones depending on what you need. As I mentioned, this raw data is not in an Excel file, it's in a CSV to make it a lot easier to open by any computer. The metrics at the top, I mentioned, we've got 0 citations with this one, not yet anyway. It's been downloaded 256 times and viewed 450 times. If you scroll down, you can take a look at the metadata, which is presented in a graphical way for folks to be able to easily read it, like human readable as opposed to machine readable. And then this gives you information about the data itself, the keywords attached to it. This is particular information about the data that was collected. So the date of collection is one, climate treatment, the different CO2 flux data, all of that. I often get a lot of questions about what these green check marks mean. If we look at, for example, mean soil CO2 flux, we can see this is a measure of soil carbon dioxide flux. Clicking this green box gives us more information about that. And this is called an annotated data set. And a lot of these are annotated on this particular one. This is a unique feature of the RT Data Center. We've been working really hard on it to make our data more interoperable, as well as more understandable with the semantic vocabulary. So basically, if I try to search for litter, like you think of, people throwing trash on the highway, you think of leaf litter, which is probably what you're looking for. And distinguishing between the two is the idea of semantics. Scrolling down a little further, we can see other information. So the people who collected the data, where they collected it, and when they collected it. That's this data set. And then for biological data, you can also add taxa. So my favorite biological taxa is crustaceans. I always pull up this one. It's a genetics data set from Derek Taylor, which is showing us a mitochondrial genome describing a new species, which I think is very cool. But you can look at the taxonomic range associated with this particular data set. And then depending on the data that you want to find, you can also search by 2 or more criteria. So say I'm looking for mooring data and I want it to be collected from 2009. Sorry about the airplane. To 2011. And I want it to be in the Chukchi Sea. Boom. I now have 4 data sets that I can use. I have access to all of this data, whatever makes sense for me to use in my synthesis work or my separate analysis. We also support social science data, as I mentioned. So this is that data set from Matthew Berman that I previewed earlier. And this is a synthetic project that he put together using publicly available census and American Community Survey data. The metadata is deposited as well as the actual data, though all personally identifying data has been removed. With some locations, we have a lot of data, more so than others. One place that would be particularly good for synthesis analysis, I know we have a lot of data from Summit Station in Greenland. Yeah, Summit Station, there we go. So we have 132 data sets that mention Summit Station in Greenland. So you can browse the map to see where those hotspots, quote unquote, of data are. And if you're putting together a comparable study, you can use that data and really just explore the catalog and see what's around. Almost done, I promise. And then in an effort to make data more reproducible, I was talking about provenance tracking earlier. And what that means is users of the Arctic Data Center are able to see exactly what data sets led to what product using the particular script or workflow that the researcher ran. So this data set from Adrian Urschel, this one is pretty well annotated with provenance relationships. So in this Frost TXT, it takes data from 6 different sources, from this input file, from this temporal file. I'm not as familiar with the file formats, but it takes these source data and runs them through this TXT script. So you can specify sources to a script or another type of application process. And then you can also show derivations. So this is what happens essentially after this script or application file or whatever. This is the output from that particular research product. And so provenance is a pretty neat thing. It's a useful tool to make data more compliant with the FAIR principles, which state that data should be findable, accessible, interoperable, and reusable. And then in addition to making data more reproducible and more fair, it's also useful for building on the work of others. So for the ones that have derivations as visualizations, for example, you can produce similar visualizations using that same code or a similar piece of code that the researcher archived with us. So there's a lot of different opportunities with provenance, and I think it's a cool thing. And then one service that we released back in May, so almost 6 months ago, is the ability to group data together into data portals that act as standalone web pages. So often researchers, they want to create a web page for their project or a particular synthesis endeavor, but they need a web developer. They have to do it on WordPress. It's a lot of work. Whereas we have put this portal service together to make it really easy for researchers to make their own website, essentially. So this is a portal that the Distributed Biological Observatory made with information about their specific work and data sets related to their objectives. So they created these about pages, they created this publications page, and they created this list of members. So that's the free form information that they added to their page. The data and the metrics are automatically created by the Arctic Data Center. So they were able to add these data sets that were interested to them so that all of the data that's important to their project can be accessed at any time. So you can create your own portal to customize your searches, and you can use any number of search criteria, including the grant number if that's easier, taxa if you're focused on a specific species, location, or any other identifier. And all of this is able to be aggregated with the metrics that are powering the Arctic Data Center. So they have 147 data sets that they're interested in, encompassing this much content, and then all of the other pieces that we talked about, the citations, the downloads, the views, all of those are automatically tracked for that subset of data sets. If you would like to create your own portal, you can just log into arcticdata.io with your ORCID, so the sign in with ORCID button, and hit create portal. It's at the top up here, create portal if that's easier for you. We have a lot of information on how to customize this, how to add data, as well as different instructional videos that one of my data fellows created. And all of this can be found on the data portals page within the Arctic Data Center. So you would go to support, working with data, data portals, and it gives you everything you would need to help create your data portal, as well as those videos. Almost done. Organizing my Zoom windows. Wonderful. So we've got a big team over at the Arctic Data Center, and all of us are dedicated to open and reusable data. So keep us updated about the projects that you find within the pages of our catalog. Data reuse is so important to synthesis science, and especially in the Arctic, where there are so many scientists active in data collection, and it's expensive to go to the Arctic. It's expensive to do your field work. So being able to preserve these products is important to essentially increase the value of your funding dollar. We've got a wide variety of data sets available. Go out there, download some data, and you can even do some quality science without ever having to leave home. And with that, I will end and take any questions. Find us at arcticdata.io, tweet at me at Arctic Data Center, and I'm happy to help you with more or less whatever you need.
Thank you, Erin, for that fantastic presentation. So if folks have questions, you can either enter them in the chat box, or you can raise your hand. So if you're not sure how to raise your hand, go to click participants at the bottom of the screen, and then you'll get the participant list, and you can hit more and raise your hand. And if you're on the phone, remember you can unmute yourself with *6, and you can raise your hand with *9.
If you don't think of anything right now, that's fine too. You can always let me know later, either by email or by Twitter or however.
We've got a question from Mike. What if you decide your file name choices were not very descriptive? Is there a way to change them?
Great question, Mike. So yes. So two sort of answers to that. So the first is that as you're corresponding with our data curation team, they'll probably let you know, like, hey, Mike, these file name choices are not super descriptive. Do you have something better or something more descriptive to call them? If they don't catch that, or if they think it's fine as it is, because we don't like to tamper with researchers' data sets, you can always go in and update your data set. And so once you do submit your data set, you'll have the option to update it, and that will trigger a new set of updates and a new set of correspondence with our data team. The only caveat I do want to put in there is that if you go in and update the files, your data set will need to be updated with a new DOI. So that's why we encourage researchers to kind of do as much information as you can on the first go around so that we don't have to constantly be updating with new DOIs for you guys. It just ends up being, it is what it is. If you need the updates, we can do them. But it's better to sort of do it all in one.
Great, thank you.
You're welcome.
We have a question from Cynthia, or a request for resources on how to make CSV friendly tables.
I do. I have a great video, actually. One of our training leads, Jeanette, she gave an awesome talk at ESA about practical data management skills. So let me poke around and find that video and put it in the chat for you. Hold on, gotta log in with all my things. I'll take the next question while I'm doing that.
Okay, sounds good. Mike is asking, did you address the long-term plans for the data entrusted to you? Will it be there forever?
So that's certainly our goal. I see Matt Jones is on the call, who is our PI. Matt, do you want to talk about our long-term preservation strategy?
Yeah, sure, Aaron. Really nice job today. The Arctic Data Center is funded by the National Science Foundation and is really implementing the conservation goals of the Arctic section of NSF. And so I think NSF has a long-term commitment to preserving this data. The Arctic Data Center is the third project that's been funded to basically operate the data repository, and I expect they'll continue. That said, there is always the possibility that funding and other sustainability issues may arise. So we do work towards replicating data to other repositories so that there are multiple copies of data in existence across the network. So we work within the DataOne network of repositories to replicate data to synergistic repositories. And we have a direct partnership with NOAA's NCEI, the National Centers for Environmental Information. And we're working on trying to create a copy of all the data within the NOAA facility as well. So that should, for some reason, the sustainability of the center wane, that data would still be accessible in an administratively independent repository as well. So setting up those bidirectional relationships, I think, is an important aspect of making sure that the data are persistent across decades.
Wonderful. Thanks, Matt, for jumping in.
And then we have a question from Patrick. Are there plans to offer cloud-based analysis services such as launching Binder or Jupyter notebooks for analysis that avoids data download?
I'm going to pump this one to Matt too. Do we have plans for Binder Jupyter notebooks?
Yeah, we currently support another project called Wholetail, which is based on Binder. And Wholetail has direct access to all of the data sets in the Arctic Data Center. And you can very easily spin up a Binder-based container, points at and integrates data from the Arctic Data Center and use that in computations. And then you can even archive like if you do a bunch of research within, say, a Binder style computational environment, you can then archive that Wholetail back to make it reproducible kind of object that archive environment linked into it. So it's one of the more advanced features we're working towards. It's definitely something that we're excited about.
Jonathan Blythe, I see your hand is raised. If you want to go ahead and unmute and ask your question.
Hi, thanks for the presentation. I've seen a version of this before, but it's good to refresh sometimes. And one part that caught me, well, I think I knew this, but the intended audience or user of the Arctic Data Center are a reasonable scientist, I think is the exact terminology. So, but what about the public? And there's a lot of interest now in being inclusive and, looking at indigenous data or maybe indigenous uses of Arctic data. So where they might not, those groups may not be traditionally in the scientific realm, are you trying to bridge to other user groups, or is that somehow defined for you by NSF that this is the purpose of the data center?
So yeah, no, that's a good question, and it's something that we're conscious of, that we absolutely want our data to be accessible to the public, and it is. There's no paywall associated with this in the same way that scientific journals are. That said, our mission is pretty narrowly defined by our funding from NSF. We are funded to be an archive for Arctic data for NSF funded researchers. So we are a little bit tied by that. We are up for renewal right now, and so I'm not sure if any of that mandate will change in the future. It's definitely something that I'm interested in doing, and I think the rest of the team is interested too, to make our data sets more accessible. One thing that I would like to do on the community outreach side, at least, is to do to revive something that my predecessor did. I think it was Vanessa Raymond, or I think that was her name, but she did data set highlights, where she would take data sets that were recently entered into the Arctic Data Center, and she would write a blog post about them, making it accessible for any type of audience. And that included often an interview with the researcher, and a little bit of an explanation of what the data set is, as well as a link to the data set itself. And so in that way, I think I wouldn't be able to do that for all 6,000 data sets in the catalog, but I could at least do it for some particularly interesting or novel or data sets from different disciplines. So that could be a way forward.
Can I just follow up on that briefly as well? This is Amber Burden. I'm also one of the co-PIs at the Arctic Data Center. And so I think when Erin was talking about reasonable scientists, she was referring to the metadata. There isn't necessarily an expectation for everyone that comes to the Arctic Data Center to kind of dig deep into the metadata. And we do a lot of usability testing on the UI that we have to ensure that it's not usable just from an academic perspective, but it's usable by the general public. That said, I think the portal's functionality provides us with a lot of scope to be able to provide customization, and we're looking at the potential to use that to reach audiences outside of our kind primary community.
Example, that's a good perspective. Yeah, the portals feature will be able to, I think, able to create that website that will be easily shareable as well.
Thank you. Are there any other questions? Oh, Marta, I see that you have your hand raised. Go ahead and unmute.
Hi, thank you. I have a question about the practice for dealing with missing data. So for example, if I have a netcdf file of 80 CTD casts and they're identified by number and number 2 failed, do I renumber those CTD casts? Do I just omit the ones that failed, or do I upload them with null data values?
I think that would largely be up to you and how you would like to represent your data. That said, we do have the ability to code for null values, and so that's certainly an option for you.
Great, thank you.
No problem. I can briefly address Ola's question, which was in the chat. She asked if there are links between different repositories, such as between the Arctic Data Center and Pangaea. And just to sort of illustrate Matt's answer to that, we're both part of the DataOne network of repositories, as I mentioned. And so this is the DataOne search capability. You'll notice it looks like a lot like the Arctic Data Center one. But if I go to, say, click on the map square for Greenland, I can see there are data sets here from EDI, from the Arctic Data Center, many from the Arctic Data Center. But all of these logos change depending on what repository it's from. So here, so some Pangaea data also is located in this square of Greenland. So you're able to leverage that network of repositories to help you narrow down your search and find data sets across those 45 member repositories that are useful for you.
there any other questions? Again, you can enter them in the chat or go ahead and raise your hand. If you're on the phone, *9 to raise your hand, *6 to unmute.
And if you think of them after the fact, feel free to email us. Like I mentioned, I'll drop our support email in the chat so that if you think of them afterwards, you can use that.
We've got a question. Did you mention tools for data conversion?
Oh, thanks, Don. So I am not sure for the more technical data conversions. I know places like Excel, you can export to CSV, or like Microsoft Word, you can export to TXT or to PDF. For the more advanced ones like MATLAB to NetCDF, I think there's an option within MATLAB to do that, just the same as Excel, export to NetCDF rather than say as a MATLAB file. But Matt might have more technical knowledge of that. Maybe not.
Sorry, just getting to the mute button. Yeah, we can support a variety of different types of data conversions, and I think we just need to know more about what kinds of conversions you're talking to about. Like Aaron said, we support a wide variety of tools in R and MATLAB and Python and other things to do data work. So yeah, so MATLAB to NetCDF in the chat sheet. You said that's definitely possible. MATLAB nicely is in the most recent versions is actually a saving their data in a format called hierarchical data format, or H5. And so that makes MATLAB files no longer proprietary in the most recent version. So mostly we've been proposing that people move their MATLAB files to the most recent version, and that works great. They're very similar to, very compatible with NetCDF. So.
Wonderful. That's technical knowledge I don't have, having never worked with MATLAB.
All right, a last call for questions. And hearing none, I guess we will wrap up. So thank you so much, Aaron, and the PIs from the Arctic Data Center for this presentation and for joining us today. This is recorded, so it will be posted on our website, on the event page, and on our YouTube channel. And you can check out future events at irpiccollaborations.org/events, and we hope to see you at many of those.
Great. Thanks, Liz.
Thanks, everyone. Have a great day.
Bye.